Okay, for this first part of this unit, we're going to be simplifying and stating the excluded values, okay? When you have a fraction, you always can simplify it, which means you reduce it, right? So if I have 8/16, that reduces to 1/2, okay? So you just divide out 8, right? Divide the top and bottom by the GCD. All right, so 8 divided by 8 is 1, and 16 divided by 8 is 2. So my new fraction there is 1/2. And then if I have 5 m's, all right, that's m to the 5th. And if I have m to the 4th on the bottom, right, then m divided by m is 1, m divided by m is 1, m divided by m is 1. Okay, any number divided by itself is 1, so what's left is m. So the 8/16 goes to 1/2, and the m to the 5th divided by m to the 4th is m to the 1st, you could say. All right, because there's only one of them. And then this excluded value here, m cannot be equal to 0, because if you just cannot divide by 0 in your denominator. All right, you look at the denominator. Cannot equal 0. Oops, cannot equal 0. All right, you cannot divide by 0. So that means m cannot be a 0, because if I have 0 to the 4th, we're here, right? 0 to the 4th, well, that would be 0, because that's 0 times 0 times 0 times 0. All right. So now going over to here, I've got 25 divided by 25, so that's 1. All right, that would be like 1. And then, but I don't have to put it, and usually if you don't have to put something in math, it's better not to. So those cancel out, and then we'll say that x to the 4th divided by x to the 3rd. Okay, these 3 cancel out. So, and notice 4 minus 3 is 1, so I just have an x. That equals x. You're always going to have 2 answers here, because you're simplifying, so that's one answer, and then you're going to do your excluded values, that's the other. So what can x not equal? Well, look at the denominator. You've got x to the 3rd in the denominator. So if I have 0 times 0 times 0, right, that would be 0 to the 3rd, and that is 0, so x cannot equal 0. And going to the next one, I've got negative, so my answer is going to be negative because that's out front. Again, the 25s cancel out, that's 1. And then x squared divided by x is going to be just x to the 1st power, right? Because 2 minus 1 is 1. All right, so, and I'll just erase that. I'm not going to put the 1 there. That's just x for my answer. All right, and then I have to do my excluded value. All right, my excluded value is 0, right? X cannot equal 0. That means the same thing, okay? If I say x cannot equal 0, that means the excluded value is 0. All right, you cannot divide by 0. So coming down here, if I look at my excluded value first, I'll look at the denominator. So n cannot equal, not 4, n cannot equal 0. All right, and then now I'll start reducing. 20 and 12 are both even, so 2 goes into it. I know 2 is a factor, and if 2 is, then 4 might be a factor, and 4 is a factor. So 20 divided by 4 is 5, 12 divided by 4 is 3. All right, so that gives me 5/3, and then my n's, I've got 1 n on top, and I've got 4 n's, on the bottom. So I've got n divided by n to the 4th. So that crosses out, and that leaves me with 1 on top, right? N divided by n is 1. You have to have a numerator. You can't just, it can't just disappear. So I'll put a 1 there to hold that place, and then I've got n to the 3rd on the bottom. So the n to the third is in my denominator. All right. Notice if I use that subtraction property, if I do 1 minus 4, all right, that would give me negative 3. So this is the same thing as 5 times n to the minus 3. Okay, but we talked about that before. If you have a negative for the exponent, right, it's not a negative number. Remember what that means is reciprocal. All right, so that makes this n to the minus 3. If I want to make that a positive 3, I move it to the denominator. All right, and now we're looking at this number 5 here. I'm just going to reduce this. So I've got all right, I've got 9 and 15, so they're not even, so 2 doesn't go into it, but 3 does. So 3 divided by 3, 9 divided by 3 is 3, 15 divided by 3 is 5. So that reduces to 3/5. And then my A's, look at the A's, I've got 2 on top and 1 on the bottom. So this is going to cancel out with one of these, so it would be A left over with A on the top. And my excluded value is 0, right? A cannot equal 0. All right, so I could write it like that. I'll say the excluded value is 0, or I could say A cannot equal 0. So those are my two answers, right? This is simplified and excluded value. So I've got a negative there. 8 divided by 2 is 4. 10 divided by 2 is 5. So that would be 4 over 5. And then these two are going to cross out with 2 of those. So that comes to m to the first on the top. All right. Or notice that 3 minus 2 is 1. So I have that 1 on top. But if I have m to the first power, I'm just going to leave it as m. All right. And that is my simplified, right? That's simplified. Now my excluded value, if I'm looking at my denominator, my excluded value is 0, all right? Or I could say m cannot equal 0 because that would have me dividing by 0, all right? There is some math space that you can do to practice that, all right? We also have on the next page, that's all basically review. Algebra 2 wise, what we add is some binomial factors, all right? And so what you would do first is you're going to, same thing, simplify and exclude, but what you have to do first is factor, okay? So looking at this top number, I cannot factor that, so but this one I can factor. And it's a binomial, so I'm going to look to see if there's a GCD, right? That's always the first thing you look for, or greatest common factor. All right, if you do math num 9 on your calculator and put in 49 and 63, you'll see that 7 is a factor of both of those. So that's my GCD, so I'll divide. Oh, and actually they both have an n, right? So 7n is my greatest common factor. So that comes out front, and what's left after I divide would be 7n here. And then negative divided by a positive is negative, so that would be negative 9. And then n divided by n is 1, so that goes away. So those are my factors there. And then now, so that's the first step. The first step is factor. All right, and then what you're going to do now, I can go ahead and reduce everything. So I've got 14 and 7, so that would be 14 divided by 7 is 2, and 7 divided by 7 is 1. So what I've got over here is 2 for the numbers. And since I factored this bit, I'm not looking at this, I'm only looking at this as my denominator. So now I have an n all by itself. All right, so that means my excluded value here One of them is n cannot equal 0. All right, because that would mean I would be dividing by 0 here. So n cannot equal 0. And then here, I've got 7n minus 9. And so if I set this equal to 0, right, and solve for that, so I'll do that. I've got 7n minus 9 equals 0. So I'll add 9 to both sides. So 7n equals 9 divided by 7. So 9/7 is my other excluded value. N cannot equal 0, and n cannot equal 9/7. Those are my two excluded values. And as far as what's left over here, though, this n divides out with this n. All right, do that in a different color, right? You got an n on top, and that's going to divide out with this n here. All right, so what's left then is the 7n minus 9. Okay, and that is my reduced answer. Okay, that's after it's simplified. And then these are my excluded values. So notice I have two excluded values. All right, so now coming to the next one, I've got, well, b minus 2, I cannot factor that at all. So I'll just leave that. But 4b and 8, they have a common factor of 4. All right, so I'm going to factor out the 4, and I'll divide, so I get b minus 2. That's now turned into this, right? So excluded value-wise, I only have one. My excluded value, I'll say, well, I'll leave that. Excluded value is 2, right? Because if it's positive 2, that would be 0. So I could what that also means is b cannot equal 2. And then now simplifying, well, I've got this, here's a linear factor, and here's a linear factor, and they're the same. But remember, you need to have something in your numerator, so we'll put a 1 there. If I divide this, anything divided by itself is 1. And then I have a 4 there. So that reduces to 1/4. Right. Okay, very good. The main thing is don't forget your excluded values there. And we'll talk about why that is in the very end of this unit when we talk about the graphs of these functions. So here we go. We've got 9 minus x and x squared minus 81. So this I know I can factor, right? This is a difference of perfect squares, so that's a nice easy one. X times x is x squared. 9 times 9 is 81, and if I have a minus 81, I'm going to have a positive and a negative. Okay. Now up here, though, so I know I'm very close to having these two be the same, right? I've got x minus 9 and a 9 minus x. So how can I make those the same? Can I just switch those around? Well, I can't if I'm subtracting. If they were added, I could, but since they're subtracting, it's not commutative. All right, because like if I take 3 minus 9, that's negative 6. And if I take 9 minus 3, that's positive 6. So notice the number part stays the same, but the sign is different. This is negative and that's positive. Okay? So what I can do, though, since it's just the sign that I want to change, right? This is a positive x and a negative 9. If I want to make these negative, I'll just divide everything by negative 1. Right? Negative 1 is always a greatest common factor. So I'll make that equal to, so negative 1 comes out front, and then that would be positive x, and then minus 9. All right, so that is just changing. When I divide out that negative 1, I change the signs. So this was negative x, and now it's positive. And this was positive 9, and now it's negative. All right? And then my denominator is over here. I've got the x plus 9 times x minus 9. And now I can divide out my common factors. And so my answer after this is reduced is going to be negative 1 over x, I don't need to put parentheses if it's all by itself, -1 over x plus 9. Okay, now my excluded values here, if I look at my denominator, all right, I have two of them. All right, there's two values that are going to give me a 0 in my denominator. So this could equal 0, right? Or this one could equal 0. All right. So for this one, x equals -9 would give me a 0, and here I've got x equals +9 would give me a 0. So these are my two excluded values. So if I'm looking at excluded values, what I'm saying is x cannot equal -9 and x cannot equal +9. Okay, these are my two excluded values. All right, so now I'm looking at the next one. Okay, I've got x minus 2 on the top, so I can't reduce that at all. I'll just leave it. But this I can factor, right? So I've got x times x, and 2 times 2 gives me the 4. I want them to add up to a -4, so I'm going to have a -2 and a -2. Okay. So now we're not looking at this. That's turned into these two factors. And if I simplify it, I've got that on top and the bottom, so that's 1 over x minus 2. Okay, and if I'm looking at excluded values, right, excluded values, I'm going to set each one equal to 0. Okay, what values of x are going to make those 0? So x equals -2 would make that 0, and x equals +2 would make that 0. So I'm looking at excluded values, so I'm going to say cannot equal x, and it cannot, or excuse me, cannot equal positive or -2. All right? Okay. So if you can factor, you can simplify the radical. All right? And that's why factoring was so important, and that's why we practiced it so much during second quarter. All right, so if you look at this example here, you've got a number on the top that you can factor out, right? You can already see that that's going to factor out, right? Looking at this example. But this one, you always want to be on the lookout for factors that you can factor again. All right, so that turned into x plus 1 times x minus 1. Okay, and when the x minus 5 went away, you end up with 2x, just plain 2x on top. Okay, now when we're looking at excluded values, okay, you see it said each of these factors, you go back up to the original problem. All right, and look at the denominator. So we have to look at x minus 5, all right, and so +5, right, if you add 5 to both sides, you get x equals 5. And then over here, you're going to have a -1 and a +1 would make those equal to 0. Okay, so you have 3 excluded values there because your denominator was x squared times x. Right, so you have 3 zeros. All right, so looking at the next one, we're going to reduce and cancel, all right, if we can. There's no factoring, so that's nice. All we have to look at is if they're the same, all right? So those two factors canceled out. And then remember your numbers. 4 divided by 4 is 1. 8 divided by 4 is 2. So that equals my final answer. And you just want to be careful. Make sure you don't lose stuff with all the canceling out and factoring. It gets a little messy. And then that would be over 2. Right? Hopefully I have all those. So that would be my simplifying part. Okay, but now I want to find my excluded value, so you go back to the original denominator. All right, well, 8 is always going to be 8, so that you can't make that equal to 0, but x plus 4, if I set that equal to 0, then x equals negative 4 makes that 0. So my excluded value equals negative 4, or I could say x cannot equal negative 4. And now looking at this next example, it's just a little trickier, all right, because you have a leading coefficient there. All right, so just to practice the factoring, the y squared, right, the numerator, you can factor out that. And then remember doing, if you have 3y, right, they're going to multiply to be 4 and add up to be positive 4, right, 4 and 4, so that would be 2 times 2, right? And that's how you get the y plus 2 times y plus 2, right? And here you have a leading coefficient, so you do the slide, right? So we go 3 times negative 2, so that would be negative 6. And then they're going to add up to be the positive 5. Okay, so that would be 6 and 1, right? And I want to have one of them be negative, and so that would be 6 minus 1 is 5. All right, and if I multiply those, I get negative 6. So those two factors, now I'm going to do my grouping, right? So that's the slide and then split the middle term. So then I've got 3y squared minus y plus 6y minus 2, right? So you keep these first terms and the last term are right here. And then they're going to do the grouping. So I'm going to look at the GCD or GCF of the first two and the second two. So these both have a y, right? So I can divide, that would be 3y minus 1, right? Actually, let me raise that up so I can write it out differently. So I'm going to divide, both of these have a y, and these both have 2, right? So the y comes out front, and I get 3y left over here after I divide these two. And then I divide over here, I get minus 1, and then I've got a plus 2, and I get 3y minus 1. So now this is my greatest common factor, so that comes out front, 3y minus 1, and then I've got a y plus 2, right? And so that was the factoring part of it. And then all you have to do is just cancel out the ones that are the same. All right, so you get the y plus 2 on top and this one here. And then again, going for excluded values, you have to look at each of these factors. Okay, so if this factor is equal to 0, that would be a negative 2. All right, so that's excluded value. And if I set 3y minus 1 equal to 0, all right, and I solve for y, that would be 3y equals 1 divided by 3, so y equals 1/3, and that's the other excluded value. Okay. All right, so let's try number 4. All right, if you know how to do it, just go ahead and stop this and then try it on your own if you're not sure, and then check when you're done. So now we've got a leading coefficient, so I'm going to multiply these together, right? So that would be negative 40. Actually, let me do that down here. I've got all this space. Let's do my scratch paper. So I've got negative 90, and then 1 in the middle. Okay, so that would be 9 times 10 is 90, right? And if I subtract 10 minus 9, I get 1. And then when I multiply them, I get negative 90. So now I can write this as 5k squared minus 9k plus 10k minus 18. All right? And then I'll just do the GCF of each one. This would just be k. And these are both even, so it'd be 2, okay? So I'm going to divide here by k. So the k comes out front, and I get 5k minus 9. And then I divide these ones, so that would be, got a plus 2 for the common factor, and I divide, and I got 5k minus 9. Okay, so this equals, oh, and so now the 5k is my common factor, and then my other factor is k plus 2. All right, so I've got 5k minus 9 times k plus 2. All right, and for my denominator, it's going to be the same thing, right? I've got a leading coefficient there, so I need to slide. Squeeze that in here. All right, so that, if I multiply those, that'd be negative 4, and then they're going to add up to 3. All right, so that, again, that's 1 and 4, right? But I've got to have a positive, 4 minus 3 is, or 4 minus 1 is positive 3. So this would be 2k squared minus k plus 4k, and then minus 2. All right, and then so now I'm going to look at the GCD of each of these. Well, these both have a k, and these both have a 2. So the k comes in front, and then I divide. So that would be, I don't think, it makes it messy. Well, I divide that, and so that gives me k minus 1. And then I divide these two here, and so that would be, well, the 2 comes out front, and then I divide, so I get 2k minus 1. Oh, that's supposed to be the same. So let me go back here, and I was too worried about my messiness, and I forgot, when I divided out here, right, one of the k's divided out, but then there was a 2 there, right, because these are supposed to be the same. So I've got $2k minus 1 is this common factor, and what's left is the k plus 2. All right, so I can write that as 2k minus 1 for a factor, and then k plus 2. All right, and then you can see, oh, those cancel out, and so when I reduce it, I get 5k minus 9 and 2k minus 1. Okay, that's the first part, the simplifying. And then when you look at your excluded values, remember, you make them equal to 0. So excluded value would be for this one, if this equals 0, that would be a negative 2, right? And if this one equals 0, then that would be a positive, I'm going to add 1, right? And divide by 2. So positive 1/2. So these are my excluded values, all right? Or what I'm saying is k cannot equal negative 2 or positive 1/2, right? Excluded means you're out. You're out of the domain. Okay, so very good. Now you can practice on MathSpace, and good luck. Ask any questions if you are still confused, and then if you finish your MathSpace, work on the review. Good job.